In this lecture, we are learn about the maximum and minimum. Okay, I think already we are learning this concept in our 12th standard. Okay, if you just forget it, go first revisit this chapter and just come here. Then I think it will be better for you. So simply just to understand this concept, just going to geometry. So first draw this picture. Okay. So here it is our independent axis, it is our dependent axis, that simply we call y is equals to f of x. And if we simply draw a functions like this, I think this is the common function that every author used to understand the maximum and minimum concept. Okay, just like this. So what will be the maximum value here? Just using this curve, you will easily see the maximum value is here. Here the maximum value will occur and minimum value will be here. Just see the tangent of the point our at maximum and minimum value. What will be the tangent? Tangent will be that. And what will be the tangent of at the minimum value? Tangent will be that. Just see in the both maximum and minimum cases, the what will be the tangent value, that it is the parallel to our x-axis, so tangent of that points will value will be what? 0. Simply just write down it at minimum and maxima, what will be a slope value? Our slope will be is equals to 0. Our air slope will be 0. Now just consider a function as an example. Let's take our functions f of x is equals to x square minus 3x plus 2. Okay. Now to find the maximum to or minimum, we have to find the first differential equations. If it is existed maximum and minimum, then there our slope value will be 0 simply. So now our target is find maxima and minima value. Find maximum and minimum value. So to find it, we have to differentiate it first. So first differentiate it, we have to first differentiate our equations. So our equations del f by del x will be 0. Means what? Means our slope is equals to 0. So differentiation value will be df by dx is equals to 0. Means this, if we write down, that is 2x minus 3 is equals to 0. That implies x is equals to 3 by 2. That's 1.5. So simple this, our at x is equals to, when our x's value is equals to 3.2, then our slope value is equals to 0. Now the question is that at this point, what will be the maximum? We all know when it is taking the maximum or minimum, then slope is 0. But we have not properly know that actually here our maximum value will be here or minimum value will be here. So to avoid this simple concept, just we are using the neighbor point. Just we see the neighbor points of it. Okay. If now just find the value of the 1.5 at the point. So at the point of 1.5, what will be the value? Just put the point 1.5 here. So I think just calculate it. I think it will be minus 0.25. Next, if we just see the point f of 1, what will be the value of f of 1? Simply it is taking the value 0. Okay, and after it will value decreased. Okay, so if you just conclude this, f of 5 less than f of 1, then what will happen here? If f of 5, we know in f of 5 our value will be maximum or minimum, and we just see that f of 1 will taking the larger value than it. So simply we can conclude here, here we would simply conclude that our 1.5 cannot be maxima. 0.5 cannot be the maxima. So simply what it implies that if it is cannot be maxima, it implies that it will be minima at point x is equals to 1.5. Simple. If it is not maxima, then it will be what? And then it will be minima. Now let's take another example. Okay, now let's take another example. Okay. Just see this type of thing. Just let's take these our graph. You can easily see that. You can easily see in this. Sorry, I think this kind of picture is better. Okay, just you can see that in this graph, what will the maximum value we cannot find. Maximum cannot find, but we can easily find a minimum value here. Here in the point, in this point, our minimum value will be here in this point. So simply if we conclude this, here we have no maxima. Here we have no maxima, and also we have here we have minima at x is equals to what? 0. Simply it is a 0. Here our x-axis at x equals to minimum exists. You just see the opposite graph of this. If you just see the opposite graph of this, okay. If you see this kind of graph of this, okay. So this is our x-axis. Here actually this is our y-axis, that is f of x. So here may not, here simply is opposite. Here no minima. Here maxima will be at point x is equals to 0. At our x 0 point, there will be maxima exist. So simple, there may be a case, there may be functions where we cannot conclude that it may or may not be, may a functions, for a functions simply we consider the, so for a function may or may not be maximum and minimum. A point may or may not be maxima or minima. Okay. Now it will be clear. Let's take another example. This kind concept will be clear. Let's see this example. Just take this one. I think it will be better. Okay. If we just see this graph, So simply you can see this. In this graph, we cannot find f of x. In this graph, we cannot find the no maximum in this graph. No maximum and no minimum. Okay, in this graph, we cannot find a maximum value as well as minimum value. And now coming to the concept of local maximum, local minimum. What is that? Just plot this graph. Okay, I think it is okay. Now if we just see plot this kind of graph, so here you can see that here there we already know that in the point of maximum and minima, our tangent will be parallel to the x-axis, means tangent value will be 0. So here you can see, simple just using this color. Here you can see in this point tangent equals to 0. In this point tangent is also 0. In this point tangent is also 0. In this point also tangent 0. In this point also tangent 0. So just using the see this curve, we can conclude that each point in this point, that is called m1 and m2, we have minimum value, and also in this point that is called here c1, let's say c1 and c2, there we have maximum value. But here actually see there have many minimum, m1 and m2, there have if you will see the many graph, there have many minimum value and also many maximum value. So in this kind of situations, we are coming to the concept of global minima and local minima. Here you can see in the minimum points, m1 is also minimum point and m2 also minimum point, but in m1 and m2 the minimum of minimum is m2. So here in m2 we call the most minimum. Here in this graph, what will be the most minimum value? In this graph, most minimum value will be m2. So this minimum value is called the global minimum. And this minimum value is called the local minimum. Actually we call it local because in local points, in the NBD points of m1, okay, just see this point, in the NBD of this point, this takes only the minimum value, but you can see m2 point in the whole graph, it's take the minimum value. Okay, in whole graph it's take the minimum value. Minimum of minima is called the global minima, and similar concept is applicable also maximum. So in this case also this is called the local maxima point. Local maximum of maximum is called the global maximum. So here it is called the local maxima. It is called the global maxima. Okay. I think this concept is clear. So this function, if you can this using this function, a function has multiple, if a function has multiple minimum and maxima, then here we are coming to the concept of local maximum and local minimum and global maximum global for a multiple maximum minimum. Okay. Now simply see that using this concept we can easily find but there are in many situations there are problems. Just see this example, then you can easily understand this. So let's just take this example. If we take our functions f of x is the just remember the logarithm optimization function. What will be our logarithm optimization function? Log of 1 plus exp exponential functions of x. So just like a logistic loss, just remember this our logistic loss function, then you can easily just it is our logistic loss function. So if we differentiated these functions with respect to x, so what will be the value? So first we are going to this value, this value in if we apply just simply using chain rule, then again we coming to first this one. What will be the differentiation with respect to x? Simply a. Then what will be the differentiation of these portions? That is exp of ax. And what will be the this portion overall? It is 1 plus exponential of ax. So it will be simply we have to first find the where x takes slope will be 0, so we have to equate it equals to 0. So simply if you see this, solving these equations is not a easy task. So simply solving this kind of equation, solving this is not trivial, is not a trivial, it is a very hard task. It's a very hard task. So we can see just simply differentiated to find the maximum and minimum is not an easy task, is not, it is a very, sometimes it will very hard task. Okay, for complex equations you can easily see it. So in such case, in the age of modern computer, actually in this age our computing power is so large, so easily we can use the power of computer. So in this age we are using not maximum or minimum concept, here we are using gradient descent technique. So in this age we are using the gradient descent. So that will learn in next chapter. That will learn in next chapter. Okay, I think what will be the problem of to finding the maximum minimums by using simple differentiations, I think you are already to learn about it. I think this lecture is all about clear. If you have any problem, please comment below. Okay, thank you.